that. Oops. Thank you, lady. All right, so I kind of want to focus on questions. I'm probably going to go over this. I have a feeling this whole idea up here on the board. I don't know if you guys can see it. I'm going to start it over again. But let me just see if anybody has any specific questions. What is the quiz on today?
Fraction, multiplication.
So it's from the review up through 1-4. That's the quick way to say it. Yeah. I didn't necessarily mean all the ideas, just what sections, right? There it is. Angeline's got it. So does anyone have questions? The way I've set this class up is we actually have a lot of time in each chapter because I like to reserve time for questions. So this class is going to run best when there are more questions. So if you are shy, you can send me a question privately in the chat. That works too. If you don't want to speak up, that'll work. I won't call you out. I'll just say I got a question and do it. It's incredible.
I have a question.
Yes.
So I remember when we were kind of going over that we were going to have a quiz today that you said we're allowed to use a calculator for the larger numbers.
Yeah, you're allowed to use a calculator. Let me see.
It's not needed though, right? But, go ahead.
This quiz, let me look at it again. This quiz, I'm pretty sure I'm not going to allow calculator. Let me see.
Okay, my question was because I can't find mine.
I might, let me see real quick. Oh, you can't find yours. That'll suck. Let's see. Oh, well, yeah. There are a couple problems you're going to want a calculator for sure. There's a couple problems with the interest stuff, you know, like the interest in an account, and that'll suck without a calculator. And then there's some percentage problems where I want you to do it to the nearest 0.1%. Let's see, Ashir is asking, let's see, what time will the quiz start? I'm going to stop lecturing or talking at least half an hour before the end of class. I've officially made the quiz due at 10:25 a.m. So I'm going to stop talking at least by 9:50 or so and get you guys started on it. So that's a good question. Let's see. It's not impossible to do this quiz without a calculator, but there are a couple where you want to calculate. Now, I really want to make sure you understand. If I give you a problem like 7/8 plus 3/9, and you just plug in the calculator, give me a decimal, you're losing all the points. Does everybody understand? This is not, can you push buttons class. But if I give you a problem like this problem, 5.6 times 1.05, especially if that's like to a 7th power or something insane, the work is setting up the equation, and then you plug in the calculator and get the answer. I love it. Right? Does that make sense? Okay. Yeah, okay. So I don't have a problem with you double checking your answer with a calculator on, you know, like order operations problems, but you can't just use the calculator and get the answer. You got to show me work. If you don't show me work, definitely on a quiz, I'm going to take points off. If you just give me an answer, I don't care if it's right or wrong, because what I'm grading is the work. So no work, lose points. All right, how's everybody else? You guys all right out there? Any other? Let's see. Certainly. Okay. So I just had a question come in from somebody. Let me see. So the question is, what about subtracting the fractions with unlike denominators? So, I mean, you can have a problem like this. What you got, Jeff? I don't know, buddy. Yeah, sure. Why is this one relatively simple? How do I make those like terms, like denominators?
So you would find the least common denominator in 9 and 27, which is 9.
No.
No? Oh,
Least common denominator means the smallest number they can both multiply up to be.
okay. So then 3? I don't know. Now I don't.
Multiply 9 by 3 to get 27.
Yes, 27 is the number they can both multiply up to be, right? So least common denominator is the same thing as least common multiple. And that came up in earlier homework. What the hell does multiple mean? We use that word and I don't know, it's like inconceivable. I do not think that word means what you think it means. What does multiple mean? Anybody know? Can somebody list the multiples of 4? What are the multiples of 4?
1, 2, and 4.
No, those are the factors of 4. What are the multiples of 4? 4.
4, 8, 12,
There it is.
16.
So multiple means what you get after you multiply. See the connection? What if you multiply that number by all the natural numbers? 4 times 1, 4 times 2, 4 times 3. So the least common multiple, this is 27, 54, 81. This is 9, 18, 20. 27. That's the least common multiple. What's the smallest number they can both multiply up to be? I like it. Then you got the idea, real quick, of GCD, greatest common divisor. That would be 9. What's the biggest number that goes into both? That would be 9. That has nothing to do with this specific problem. So here you would multiply this by 3. Why do I have to do that on this problem? Why do I need LCD? Yes, you can only combine like terms. That's really, yeah, you can only combine like terms. So they need to have common denominators so that they're like terms. I have 7 of these minus 4 of those. Shit. Okay, now I have 7 of these minus 12 of these is how many of these?
-5.
Yes. So I made them into like terms. I like it. Do I need common denominator on this kind of problem? What do you got, Jeff? I don't know, Jeff. Sure. Do I need a common denominator? No, I don't. Because now I'm multiplying. Multiplying does not require perfectly like terms. It doesn't. And again, I cannot add x plus x squared, but I can multiply x times x squared. Multiplication and division is much less restrictive. It doesn't really care. It's all right. Addition and subtraction, oh, it must be the same. It must be the same. Multiplication, division, whatever, man. Okay, maybe. So this one, what could I do?
You can cross reduce the 27 and the 9.
Actually, even better than that, right? And then
You just multiply across.
okay, is that all right? Let's do one more real quick, a little bit harder. If I had something like, what do you got, Jeff? Let's do, no. Sure. Sure. All right. That works. Now, the way I would do this problem is I would say, what number do these have in common? What's the biggest number these have in common?
5.
5. So 30 is 5 times 6. 25 is 5 times 5. Now I can see exactly what each one is missing compared to the other ones. What is this guy missing that he's got?
6.
6. And he's missing a what?
5.
Another 5. So now I get 35 over 5 times 6 is 150 plus 54 over 150. Let me stop for a minute. So when the bottoms get a little bit more complicated, this is the method that I like to use. But some of you guys might just do this. 30, 60, 90, 120, 150, and then 25, 50, 75, blah, blah, and get to 150. Right, that's listing all the multiples because you're trying to find the least common multiple. That's beautiful, but it also can get disgusting. So I kind of like doing it this way because then it breaks it down to what do they already have in common and what are they each missing? And then I could just give it to them. It's such a beautiful idea. You're trying to make the bottoms the same. So what are they missing? What's making them not the same? And they just give it to them. It's crazy. It's a kick-ass idea that comes up a few times in mathematics. That's why I like to teach it that way. All right, is that all right? And then of course you just combine these. What do you get? 89 over 150, which doesn't look like it reduces.
I have a question.
Yes.
So for the top right, how come that's multiplied by 6? Like I understand it's at the bottom, but why choose 6?
I cannot change just the bottom because I'm changing the number then. I can't go, man, I don't like this problem. Let me make another problem. Because that's effectively what you would be doing if you only change the bottom. So I do sometimes get somebody who will do a problem like this, 1/3 minus, let's say 2/3 minus 1/4. And they'll go, all right, this is times 4, and this is times 3, so 2/12 minus 1/12. Anybody see the problem there? You are effectively saying that 3 equals 12, because the top didn't change. Or you're saying 1/4 is the same as 1/12. That's obviously not true. So you created a new problem that you like better. That's not allowed because that's never going to lead you to the right answer. You've got to change top. If I multiply by 5 over 5, what did I actually just multiply by? What is 5 over 5?
1.
1.
And when you multiply by 1, do you change anything? No. So I multiply him by 1, I multiply him by 1, so that's the same problem. I didn't change anything. It just looks different. No?
Okay, thank
Because
you.
you're welcome. You're welcome. And I'm not coming down on you, Carrie. This is a good general question. We all know that 1/2 equals 2/4. They are the same number, right? They're both 0.5. Do you guys see what I'm saying? So 9 divided by 25 is the same thing as 54 divided by 150. If you don't believe me, do it. You'll get 0.36 either way. 0.36. I did it that fast. I kick ass. Oh, you're welcome. Sorry, it's my one skill, so I got to show off every now and again. If you don't believe me, you can do it. Tell me I'm wrong. Please try. All right. So is that all right? Is that all right? So I really want you to understand, fractions are not as evil. I understand why sometimes people are like, sometimes you make an LCD and sometimes you don't. What the So I want it to make sense why you make an LCD. Add, subtract, I gotta have like terms. Multiply, divide, I don't have to have like terms. That's why I find an LCD when I add subtract, and I don't have to find an LCD when I multiply divide. It's that simple. That's what I hope. Okay. Anything else? I do have one thing I want to definitely do, even if nobody asked the question, but I don't want to do it quite yet. What time we got? Okay, we got time. Okay, I'll do my thing. I want to go over something from that section 1.4 because I think we could all benefit from seeing it again. But before I do it, let me see if you guys remember this. If I were to take something and put it here, so like do distribution in reverse. Do distribution in reverse. Let's see if I make that better. Is that better? A little bit? Sure, okay. What would I put out here?
2.
2, right? Why? How did you
Yes.
tell? Because they both have a 2. Right? They
2,
both have a
yes.
and then what's going to be inside?
X plus
4.
4.
Yes. Does everybody get that idea? It's just distribution in reverse. It's like, what did each thing get? They each got a 2. How can you tell? Because they each have a 2. That's what they all share, right? All right. So with that idea in mind, if I had something that cost $50 and I want to increase it by, Jeff, you can do it, 6%. Right, I'm the store. I paid $50 on it. I want to make a profit, so I'm going to increase that up. Right. I'm going to mark that. If it was our bookstore, it'd be more like increased by 35% or something. But let's not be our bookstore. Let's be better. I think you all know what I'm talking about. Maybe. Anyway, how do I do that? Just tell me how you would do. How would you figure out what the new price is?
Well,
Like
6% of 100.
So don't tell me the steps you would take. Tell me what it is you're trying to do. Does that make sense? Like, just how do I find the new price? How would I find the new price? How do I do that?
We can add 60% with
How do I figure out 6%? Now, real quick. Yes, Andrew. Just a second. Hold on to that idea. Hold on. I got somebody doing something like this. Is that an increase by 6%?
No.
That is just an increase of 6 cents. That's not a 6% increase. If this is your store, you're going to go out of business very soon. Very soon, right? It's not going to cover your overhead. You guys semi with me? So don't just add 6 cents. If somebody said, I know the cost of the car is a lot, I'll take 10% off, and they end up subtracting 10 cents, did they do what they said they were going to do? Hell no, 10% of the car price. So, increase by 6%. So how much will I increase this by? It would be 6% of
50.
50, which is this, right? 6%, 0.06 of times 50. And then what am I going to do with that amount? That's not the new price. You wish it was the new price. But of course, I'm going to take that and I'm going to do what?
Add it to the original price.
Add it to the original price. I love the tone. So he goes, of course you're going to do this. Some of us need some help. So I appreciate that. Now here's the connection between what I did up here and what I'm about to do. Can you see something that these both have? Both these terms. What do they both have?
50.
50. All right, so 50 divided by 50 is 50 divided. So I'm going to do the exact same thing.
1.
I'm going to take the thing they both have out. So what's 50 divided by 50?
1.
1.
And what's this business divided by 50?
0.06.
0.06. So the shortcut to increase the price of something by 6% is to multiply by 1.06. What would I multiply something by to increase it by 12%?
1.12.
1.12. What would I multiply by to increase it by 35%? So we can be the bookstore.
1.35.
Holy shit. What would I multiply by to decrease it by 10%?
0.9.
Yes, 1 minus 0.1. So it works for increasing or decreasing, for markups and for discounts. It's a beautiful shortcut. And the more, it's even, the even more beautifulness of it is, what if I wanted to do this increase 7 times? I want to increase it by 6% 7 times. Then I would just have to do this. You could do it, Jeff. To the 7th power. And I can get the final answer. Bam, I have no table to fill out. I know they make you fill out some tables, but that's just to get the idea. And then the shortcut, I can use exponential growth to help me do that. Okay, maybe. Oh, sure, Lauren. I'm sorry, I called somebody else. Somebody's asked me a question. I don't know who they are. Let me see. All right. So this is what kind of growth?
X.
Increase.
Exponential growth. And the other type is just where I add the same amount over and over. And that's simple interest example. That's linear growth. Okay, maybe. Linear deals with slope, and slopes don't change on a line. So that's why I keep adding the same amount. Exponential is the increase increases. Let me say that again. The amount that I'm going to increase it by increases. It's not a constant. It's increasing. All right. Maybe. That's why we use it to model population. Why does population growth follow exponential curve? Because the more people you got, the more people those new people can make. And the new people they make can make their own new people. And then you get to a situation where you're like, holy shit, we need to find another planet. Okay, maybe. Sorry. New people making new people. Oh yeah. So if I had a $28 shirt that was going to be discounted by 10%. So like I said, the shortcut would be 28 times 1 minus 10%. A markup would have been plus. A discount minus. So I got one whole thing minus 10% of that thing. So it would just be 28 times 0.9. Is that cool? 1 minus 10 cents? 0.9? And then whatever the shit that is. I think it's 25.20, is that right? I don't know. It's too early. Yes, okay. Become a 0. Okay. I like it. Now here's what's interesting. If I was going to decrease this by another 10%, I'm not going to end up subtracting the same amount. So, I mean, if you do this step by step, 10% of 28 is $2.80. And if you do 28 minus 280, you get there. Let me stop there for a minute. Is that all right? So that's the shortcut to doing that way. If I wanted to take 10% off of this, is it going to go down by 280 again? if I wanted to take this price and reduce it by another 10%, is it going to go down by 280 again?
Now it's going to go down by less.
It's going to go down by less because now the cost is less. 10% of this is less. So now if I wanted to do this twice, I could just do that. Apply the 0.9 twice. And then I would see what it would be after one more discount. So somebody help me out. What is 28 times 0.9 squared? 252, so 22. 2268. Sorry. Might be off by 10 cents. I don't know.
No, you got it right.
Yeah. 2268. That's what it would be if I did not 10% and then another 10%. So do you see how stores sometimes they'll play into people's misunderstanding? You go into a store and it says 10% discount, and then there's another 10% discount on top of that. That ain't 20% discount. It ain't. Because that second 10% is of a smaller number. So it's not 20% total off. It isn't. Anyone curious what the percentage off actually is? Or are you like, dude, this is enough? Anybody interested at all? Does everybody understand what I just said? That is not a 20% decrease from where I started. It isn't. How much did we actually take off from the beginning? After two of these, how much did I take off? I took off $5.32. Is that right? $5.32 difference here, right? So I took $5.32 out of 28. If I do this, I can figure out what. Sorry?
$6 point.
No. 6 would be 22, and we didn't quite make it to 22. So it's not more than $6 off. It's 28 minus 22.68, which is 5.32. And if
Yeah, that's fine. Yeah.
if I divide that by 28, I can see what the actual discount was. Everything I'm doing right now about actual discount is extra shit. If you don't like it, you can kind of ignore it. I would hope you wouldn't. So what is 532 divided by 28? Anybody?
0.19.
0.19, exactly?
Yeah.
Neat. I like it. So is that a 20% discount?
No.
No. It's a 19% discount. Okay. That's why if you get something for half off and then there's an extra half off, it's not free. But some people go into the store thinking that. It's like, holy shit, well, I'm just going to take these and walk away. Wait a minute. What are you doing? All right, enough of that. Any other questions?
I do have a question.
Yes.
Okay. So you said, okay, right here we were doing exponential. That's correct, right? To the times. So it's exponential? Or is that only, I'm a little confused because you were saying that in order to do the amount of the discount from 2520, you would just put it to the second power.
Not from 2520.
Oh, okay.
If I wanted to go 28 and then do 2 successive 10% off, I would do this twice.
Oh, perfect. Okay.
One 10% off. This is 2 10% off in a row, right? 10% of 10%.
Okay. That's what I was, because I was confused because I was like, wait a second. That doesn't make sense, but that's why it didn't make sense. It's because that's what we weren't doing that. Got
Yes.
it. Thank you.
Okay. So this is what you would do if you had a situation where it was like 10% off and then you have a coupon for 10% off on top of that. This is what you would do to figure out what the new price is. Because it's not 20%, like we just talked about. Are you guys with me on that? It's not 20. You can't just add the percentages and yay. No. Sorry. Yeah, I like it. What's the only way you can make something free is if you had it for what percent off?
100%.
100% off. Anything less than that, I don't care. If you had it 90% off and then you had another 90% off on top of that, it's still not free. It's a lot less money, but it ain't free. Does that go against what you feel should be true? Does it feel like they should be paying you to take it if it's twice 90% off? But again, it's 90% of a smaller amount and blah, blah, blah. Same thing. Okay. Enough of this. So I do kind of feel bad for you guys because I don't know if you picked up on this, but I do tend to go a little further with problems than you necessarily need to yourself. So from a student standpoint, it might be confusing sometimes to know where your work is going to stop and where it's just Jeff going a little further, but I want you to understand the whole thing. I know I'm crazy. I am. So when I'm discussing something, you might not have to do everything that I do. It's just the idea I'm trying to talk about. So the homework should be a little simpler than some of what I do because I'm trying to expand on the idea. Anyway, okay. Anything else anybody want to look at? How much time we got? Don't let me go too far over. I want to give you enough time. 9:30. What did I say? Yeah, we got about 18 minutes left, maybe. Anybody else have questions?
Is the quiz going to be, is there a section for quizzes or is it going to be in the homework?
Oh, thank you. There's an excellent question. So when the time comes, I'm going to make this show up. And where it's going to show up, it's a module on Canvas. Is everybody with me? Does everybody understand what I mean when I say module? You all should, because you should have worked through one of those already. And let me show you where it's going to be, just so everybody is really, really, really aware. Let me make the module. I just like to say module. Module. Let me make the module awake. There we go. And let me show you this. Let me show you something. All right. Bam. So here I am. I'm a student. You go to modules. There's the extra office hours link. And then right below that, right now you can't see it, of course, because it's not time yet. But as soon as the time comes, you'll see a quiz here. So real quick, you don't have to print it out unless you want to. So you don't have to do the work on the quiz unless you want to. Do the work on another sheet of paper or the quiz, scan it, submit it. The same place you got it, just like homework. Is that cool?
How much time do we have? I'm sorry.
You'll have until 10:25 a.m. So
Okay,
I try to have
and
the quizzes live
we
within the class. Sorry, go ahead.
We're not coming back to Zoom, right?
No, you're going to stay
Okay.
on Zoom. You're going to turn your
Okay.
camera on, stay on Zoom, especially because if there's any technical difficulties with getting or submitting it, I want to be right here to help. All right.
Okay.
I like
Wait,
that.
so we need a camera right now or today?
Yes.
All right, sounds good.
Okay. Yeah, sorry. You're definitely going to have to submit it. Oh, yeah. So I understand some of you guys don't have a camera. I understand that. So I'm just going to have to trust you. But to be honest, I'm thinking about just asking everybody to turn the camera on during normal class anyway. It would make me feel a little better. I appreciate that quite a few of you have your camera on. It makes me feel like I'm talking to people instead of just I've gone crazy and I'm talking to my blank TV. And my neighbors are looking in my window like, should we go in? So that would make me feel better to see faces and reactions. I'm still playing around with this is how my first quiz is for every class. The second quiz might change a little bit as far as how I work it, but we'll see. Oh, look at this, more cameras coming. Oh, thank you guys. I see people. I understand. So some of you guys have your camera off for various good reasons. I understand that. But especially when the quiz starts, I appreciate turning on unless you absolutely can't. And you know, I'm just going to have to work with that. Let me see. Anybody else have any questions? I'm going to stop here in a little bit. Well, we still got like 10 minutes or so, maybe.
I do. Could you please do one more of the increased percentage?
Mark Zuckerberg. I like that. One more of the increased percentage thing.
Yes, please.
All right, so let's do a bank thing. Let's say I have $4,000 I put into a 3% account. All right. And let's first say it's a simple interest. What does that mean if it's simple interest?
It's not compounded.
Not compounded, meaning I add the same amount each year. Simple interest after 7 years. So how would I do that? What amount am I going to add each year? I got $4,000. How do I figure out how much I'm going to add in interest?
Times 1.03.
No, not quite. I know what you're, so again, this is the simple interest problem. That would work for the first year, but then it quickly breaks down because this is not exponential. So I'm gonna, 3% of 4,000, that's how much I'm gonna add each year. So what is 3% of 4,000? It's 3 times 40, which is 120. So this should feel a little familiar. You had to do this in some of the homework. Wendy, you're like always bouncing. You're like Dwight on his little ball in the office. So if I take 4,000 and I'm going to add this, how many times am I going to add this?
7
7
times.
years.
7 years worth of this. So then where am I going to end up? 7 times 120. I'll do it. There we go. So again, if you can't get your camera to work today, that's fine. It's okay. I'm going to have to trust you. In the future, I actually might make it so that you don't have to stay on Zoom, but I'm trying to work out some other ways to do this. So what if I did it compound interest? This is the one that does the 3%, but then it does 3% of the higher amount the next year, and then it is 3% of the higher amount the next year. So we know the shortcut for this, don't we? Do we know the shortcut for this? I would do 4,000 times what to the what?
Times 3 to the 7th power.
No.
1.03.
1.03 to the 7th power. I want one of these plus 3% of these 7 times. And this is going to be higher than this, obviously, because it's growing faster each year. It's not growing the same amount each year. And so whatever the hell that is, I don't know. Anybody get that? No? Nobody?
1,919 and 49.
Yeah, and actually round up to 50. Although I agree with you, the bank might round down. I don't know. All right. So a little more money, right? Almost $80 more if you put it in the compound account. Okay. And one little thing, this is going to be in our future, but you guys remember mx plus v? mx plus v. That's why that's linear. It's in the form of a line, but that's a little bit in our future, but it should be in some of your past. It might be in our deep dark past. I don't know. Oh, well, I mean, that's what this is exponential growth. That's what that is. Somebody's asked me a question about it. Do you mean like if they give you a chart, how to tell if it's exponential growth? That's the other kind of problem they did. Is that what you mean? Yes, okay. What time is it? Okay. So if I had a chart like this, what you got, Jeff? Oh, man. What's your problem, buddy? There. Versus a chart like this. All right. Which one of those is linear growth? Chart 1 or chart 2?
2.
How can you tell?
Because it's increasing by the same amount every time.
Yeah, every time it adds 5, that's linear growth. Linear is you keep adding the same amount. Now, what is 6? 2 plus 4 is 6 plus 4. Oh, shit. Not linear. How do I check if this is exponential? I divide. 6 divided by 2 is? Thank you. And then 18 divided by 6 is?
3.
3.
And 54 divided by 18 is?
Probably 3.
That's a good guess. So if I keep multiplying by the same amount, that would be exponential growth. Because why is this called exponential? Because this is 2 times 3 times another 3, so 3 squared, times another 3, so 3 cubed. Right? Try it out. What's 2 times 3 cubed? That would be 2 times 27, which is 54, which is what that is. That's why it's called exponential. Exponents are repeated multiplication. So if I see a chart where it's repeated multiplication, it must be exponential growth. So how do we check? You divide each one by the one before, and if it's the same number, exponential. If you subtract, it's the same number, linear. If you do both and it's neither one, then it's neither one. It's some other kind of growth. Those aren't the only 2 types of growth. Right? There's quadratic growth, and there's polynomial growth, and there's logarithmic growth, and there's all kinds of freaking growth. Right? There's a growth you should go see a doctor about. Stuff like that. All right. Let's see, what time is it? Oh yeah, it's about almost time. Any last second questions? I can go ahead and get you started. Give you a little bit more time. How's that sound? That sound all right? So again, it's not impossible to do this without a calculator, but there are a couple that require you to work with stuff like this. In fact, while I'm thinking about it, anybody still need this?
I still.
Okay.
How do we get to the quiz? I think I missed that.
So I showed earlier, it's going to be on Canvas in a module. It's
Okay,
gonna be
modules. Okay.
module down. It's going to be called quizzes.
Okay, got it. Thank you.
I can make it active in a minute in case you're on there right now. You're like, I don't see a quiz. Well, I haven't made it active yet. All right, so everybody got this now?
Yeah.
Yes. Obviously, I don't want to help you out too much on the quiz. By the way, I've had people get upset at me when I didn't help them during a test or a quiz, and I'm like, oh well, too bad. All right, here we go. Let me see here. I'm going to make it active. Hold on. Don't look for it yet. Don't look for it yet. Okay, now it should be there. So go ahead and log into Canvas. And then let me know if you have any trouble finding it. Let me make sure I've got it set up correctly. Please release me. Let me go. All right, let me see. Is everybody doing okay out there? Yes, Ian, anything you upload to me, I would like it as PDF. Other things might work. PDF always works. Oh, why do I have no submission?
I'm sorry, I have a question.
Yes.
So how do we submit this? I'm sorry if you already answered this question.
Same way you submit homework.
But there is no submit.
Oh, there is now. Sorry. I just
Okay, thank you.
forgotten to make that. Good. Thank you. So there should be now. If you refresh. Anybody having trouble? Everybody should have it and be working on it now. Is that true? Everybody with their camera off? Are you somebody that it's impossible to turn your camera on? Is that true? There's a few people I know that can't.
Yeah. And I think I might have a lot of background noise, so I typically leave my microphone muted.
Yeah, I didn't say unmute. Definitely mute. Mute is good, but camera on is good too. And like I said, you have until 10:25 to do this. Oh, am I still sharing? No. By the way, guys, when you're about to turn it in, let me know. Because I don't want you to leave until I tell you that I got it. Technology.
Professor, I don't have a printer to print it. Can I work on the laptop, please?
Sam, I can't understand you. Maybe put it in chat. Your audio is just breaking up a lot. You don't, yeah, again, you do not need a printer. Just do it on your own paper, just like homework, and then scan it and turn it in. Who just came in?
Can we use the calculator for the first problem?
Yes.
For the first problem, I rounded to the nearest hundredth for most of them, tenth for most of them, or hundredth for some of them, tenth for some of them. So when I added up all the percentages, I got 99.03, but it looks like I think I did it right.
Okay. Anytime you round, they might not add up to 100%.
Okay.
So the first problem, I do want you to round. Now round up, now round down, round. The way that rounding works. Yep, just the 3 questions. Let's see. Melissa, I got yours. So Melissa, you're free to go if you want to. Oh, sorry guys. I should have done this earlier. This is going to be an exciting part of this.